Hey everybody, this is Dr. Z once again for Web Tutor Online Phys 101 series. And you remember the other day we actually did some basic quantities, some derived quantities, with some mathematics involved in physics. And so today we're actually going to do some real physics. Yep. Forces. That's important stuff right there. Right, so everybody remember what definition of a force is? It's a push or a pull. Yeah. What's really important is the measurement unit. It's measured in newtons. So we can probably work out a combination of basic units that would make up the units of force, but it uses one of those special derived units, newton, right? Of course, after Isaac Newton, right? Anyhow, so a force actually will categorize as a type of quantity that has magnitude and direction. So that brings us to two different types of quantities here now. One that has just magnitude and one that has magnitude and direction. So a lot of the quantities, a lot of the basic quantities that we looked at the other day, they basically just have magnitude. So it's a measurement, it's a value that we take, and it just gives us an idea of the magnitude, the scale of what we're measuring. However, those are scalar quantities. When it comes to vector quantities, we can actually get a magnitude and it also gives us an idea of what direction this measurement is heading in. Right? So an example of a vector quantity would be like velocity, or you can even have, in this case, forces. So they can be acting in a particular direction, up, down, east, west, right? And that actually gives us a little bit more information rather than just the magnitude. Right? Now, dealing with forces, we can have a static situation or we can have a dynamic situation. So when the forces are actually balanced, that means though they may be acting in opposite directions, they're canceling each other out, they're going to be considered to be in a state of equilibrium, right? Because no one's going anywhere, right? And that situation is when the forces are actually balanced. Now, forces are going to be acting in either a horizontal or vertical direction here. So there also can be a situation where forces can create a turning effect, which we're going to cover under moments in the next lecture. So we're not going to touch that one too much. But that's one of the conditions as well for equilibrium. But the most important condition here today is that the sum of the forces in one direction will equal the sum of the forces in the opposite direction in order for us to be in equilibrium or a state of rest. Right? And simply put, it just means that the forces are balanced, they are canceling each other out, and as I said, no one's going anywhere. Now, when the forces are actually not balanced, we need to determine now what is the resultant force. The resultant force simply is, well, what remains after we cancel the effects of each other. There may still be a force remaining, and that may be acting in a particular direction and have a magnitude. And so we add or subtract depending on the directions of both forces, or the combination of forces. And that gives us an idea of the resultant magnitude and also the direction. So they're both acting in the same direction. We add them, and hence we get the sum of the forces, giving us the magnitude, and of course the direction that they both were acting in will be the direction of the resultant. If they're acting in opposite directions, again we subtract now, and the remaining force will be the magnitude of the resultant, and the direction that resultant is going to be going in, right? However, if I have two forces and they're acting at 90 degrees to each other, or they're perpendicular to each other, we can't use that method to determine the resultant. So we use a mathematical theorem called the Pythagoras theorem. Now this is maths, and I'm sure Web Tutor Online is going to do some math lectures, but today we're just going to just talk about this theorem really quickly, and we're not going to go into any details of it. So Pythagoras has a theorem that basically governs right-sided or right-angled triangle, which is there's a 90-degree angle in it, and we're able to determine length of the sides, or the magnitude of the sides, based on his theorem. And his theorem is stated right there. C squared is equal to A squared plus B squared. And if we want to find the resultant force, we simply find the square root of the sum of the squares. And there we go. We get the resultant and the direction of the resultant. Right. Now, if the forces are actually acting not at right angles to each other, I mean some other angle, in this case 60 degrees, we're going to have to use scale drawing method. Right? Scale drawing method simply means we're going to use a ruler and a pencil. We're going to assume a scale of 1 centimeter representing a certain amount of newtons, and we're going to draw our forces using a protractor to put in the angles between those forces, and then complete the parallelogram. After we complete the parallelogram, we're going to draw in our resultant, or diagonal, which will be our resultant, and take a ruler and measure that, and that's going to give us the length or the magnitude of our resultant and the direction. Right? So I'm hoping this information is useful to you today, because we've covered basically all the ways you can find the resultant of your forces acting on an object, and we've also covered the units that we're going to be using to measure our forces, because from this point on it's going to be a lot of heavy physics. The next lecture we're going to be covering turning effect forces that actually brings about moments. Right? So don't forget, like us, subscribe us, vote us, comment, send us a comment. Please keep revising your lectures. Look out for the other lectures, because at the end of all this, I want to give you an exam at some point, and we want to see how much you really remember. Okay, so until then, keep your stick on the ice and keep reaching for the stars.